Today's lesson deals with proving triangles are similar with angle-angle similarity. Now, this similarity is different from our congruence postulates that we had a while back. It only works on similarity. This little postulate does not work on congruence, but it's very simple. When applied to triangles, it says that if you have two angles that correspond to two other angles on another triangle, and they're congruent, then the two triangles are congruent. Sorry, they are similar. So once again, this angle corresponds here, this angle corresponds here, therefore the triangles are similar. This is called a what?
Congruence statement? Or
similarity statement. Write that down real quick. This is a similarity statement. On your test, you will be asked to write similarity statements. So make sure you know what it looks like. It has a little tilde in the middle. These are similar. Do the letters have to be in a certain order, or does it matter? Letters must be in a specific corresponding order. So yes, order does matter. Now, example 1's pretty straightforward. We're examining the angles, comparing them. We're looking for two angles to correspond per triangle. So right here we have 90 and 68. Do we have that here? No. All right. But we've learned how to find missing angles. How could we find angle F? Yeah. Subtract the other two angles from 180. So if I do 180 minus 90 minus 22, I know with mental math that I will get 68. Now do we have two angles on each triangle that correspond and are congruent? Definitely. So we have the 68s correspond and are congruent, and we have the 90s that are corresponding and they are congruent. So the question says, are they similar? What would you say? Yes, they're similar. If they are, write a similarity statement and explain your reasoning. Well, why are they similar? Because angle-angle similarity. We found that angle-angle similarity due to this right here, so make sure to write in the numbers to prove it. And then we need a similarity statement. So that looks like triangle something is similar to triangle something. All right, if you pick ABC, make sure it corresponds. DEF. That's a good similarity statement right there. ABC is similar to triangle DEF. What I want you to do now is go down and try the checkpoint below. Here's the checkpoint. Look at the pictures, read the directions, and go. All right, here we go. Determine whether the triangles are similar. If they are, write a similarity statement. So real quick, do they match up right now? No. So we got to find some of the missing angles in that picture. So maybe let's find Q. Subtract these from 180, and what do you get? 31. Now do they match up? 31, 31, yes. 78 with a 78? Yes, they match up. So are the triangles similar? Yes. Due to angle-angle similarity, write a similarity statement. So triangle something is similar to triangle something. Who has a good similarity statement? P, Q, R, H, G, F. Let's double check. Does F match with R? 78, 78? Yep. G match with Q? Looks good. Yep. All right. That's a nice similarity statement. Now here's one thing. If it says explain, and I didn't really emphasize this earlier, you really need to tell which angles you proved are the same. So on this picture, it's really easy, so that's why I picked this one. So which angles did we compare? Oh, we found that this one is 31, and it corresponds to this one's 31. This is angle, how do you name it? Angle Q corresponds and is congruent to angle G. What's the other pair we looked at? Oh, we looked at R and F. Angle R is congruent to angle F. And really, this is where the angle angle comes from. We compared these two angles are the same and these two angles are the same. That's why you can say angle-angle similarity. This is something that I expect from you when it says explain in the future. So make sure to write that down. The next one, did the numbers match up right now? Nope. All right, let's find one of the other ones. Maybe find F. What's it come out to be? 180 minus 110 is 70. 70 minus 27 is 43. Do they match? No, they don't match. So this is a not similar. And that's all you'd have to state on that one. Example 2 is a little different. Show the triangles are similar. Now it names the ones you should be looking at. So it says look at RTV and then look at RQS. Well, RTV is this small one on top and RQS is the bigger one that encompasses it. How many angles do they give us? They give us a 49 here and a 49 here. Yeah, but usually we have 4 angles. We look at 2 pairs of angles. What's going on? How can we find, or can we say angle, angle? Okay, but why is angle R the same on both? It's shared. What was that property for shared? Reflexive. Please make note of that. You're going to see that all year long. Those angles are reflexive. If you look up here, they both contain angle R. And if you draw them separately, they both have angle R up there at the top. So Q is 49. That angle T, RTV right there, is 49. And then they both have angle R. So if you saw it like this, it would be very simple. But they nest them inside each other, and you have to remember that reflexive property. So are they similar, yes or no? Yes, these are similar because angle, angle similarity. And give me those angles that match up real quick. I want to see if you can name them correctly. Angle Q, I agree. You can name this angle Q. But I don't agree with angle T. 3 letters. Okay, T must be in the middle, so like RTV would be a good one. This one can be named with a single letter because it's by itself. Angle T has a couple angles right here beside it, so a single T is not good. RTV, where T is in the middle, is a good angle name. Let's keep that in mind for these up here on top. So we're looking at these 2 angles. Can you name them with just angle R? I'd say it'd be okay. Let's practice naming with 3 letters though. How do you name it on this small triangle right there? CRV, I like it. And then on the big triangle, look right here, might help you, QRS. And those would be good names. On example 2, part B, they don't give you any numbers. They give you angle marks on 2 of the angles though. And they put these little triangle things over here. What could we say? What could we say on this one? Anybody have a guess? Could we prove any other angles? All right, Becca. These are corresponding angles. Now I will show you. These are corresponding angles. If you have parallel lines, we highlight them, then we cut them with a transversal. So, looks like this. Whenever you just saw that picture back a while back, you would definitely say corresponding. So now it's applying it with triangles. Those are corresponding angles. Now do we have 2 angles on each triangle? Yeah. Definitely, definitely. So what we're going to do now is we're going to focus on naming them. Does it say write the similarity statement? Nope, we don't have to do that this time. So let's focus on saying yes, angle, angle, similarity, and now we're going to name the angles. How do you name this angle? Can you name it with one letter? You can because it's by itself, so let's try that. Angle L is congruent to, what's it match with over here? Can you say just N this time? Okay, ONP is a better one. ONP. And that's a better answer because if I say angle N, which one is it talking about? It'd be hard to tell. So 3 letters would be better on that one. All right, and now let's do the other one. How do I name this one right here? MNL, that works. Is congruent to, and then it corresponds over here. Can you say 1 or 3? Just angle P is fine because it's out there by itself. There's your angle, angle proof, your explanation that those are similar shapes. Good job. Go down and try this checkpoint right below. It should remind you of a very popular reason that we've used. See what you can do. One thing you need to remember on this particular checkpoint is that these triangles are touching each other. And a lot of times when they're touching each other, you can add some information. The key piece that a lot of you saw was that these angles right here are going to be the same. So why can I put these marks at these spots? Those are vertical angles, and that's a very, very important reason that you're expected to know in this class. Very important reason. Now do I have 2 angles on each triangle? All right, let's name them. So let's start over here. What's that one named? Yeah, we can say angle C because it's by itself. It's congruent to angle F. There's one angle. Now the other one. How do I name that one? Can I not just say D? Why can't I say D? Not by itself. I like it. So CDB. I like that. CDB is congruent to FDE. That's a great response. FDE. There you go. These are similar. Yes, they're similar. Or you could say yes, AA. Yes, they're similar due to angle-angle similarity. This one's a little bit more challenging, but it's very practical, and it's a very, very popular question on the ACT. This one's really, really popular. A lot of times, they're only going to give you a paragraph, and you'll have to draw the picture yourself. But since we have these notes, kind of provided with a picture anyway, so it's pretty helpful. What you need to be able to do is read that paragraph, though, and kind of visualize the picture from it. So it says a lifeguard is standing beside the lifeguard chair on a beach. The lifeguard is 6 foot 4 inches tall and casts a shadow that's 48 inches long. The chair casts a shadow that's 6 feet long. How tall is the chair? So we're trying to figure out the height of this chair, and they noted out here with an X. Now, be very careful on here. There's something that will possibly trip you up. This says 6 feet 4 inches, 48 inches, 6 feet, X feet. What do you notice about those terms that I've read off? Might need a conversion. So is it better to go to feet or to inches in this problem? Probably inches would be easier. So let's do 6 feet over to inches. How do we do that? 12 times 6 is 72 inches. That's 48 inches. All right, now this one, 6 feet 4 inches. Well, we already know 6 feet is 72, and 72 plus 4 is 76 inches. Now we just got to figure out this one over here. Okay. So yeah, you can change it to inches and change it back to feet at the end. That works. So the key thing is knowing how to set up. When you have 2 triangles, and you're missing some parts, but you know they're similar, then you need to set up a proportion. So please, make sure you get this proportion. This is very important, especially for the next checkpoint. For some reason, I always like to put X up here. It's just a habit of mine. If we all do the same kind of thing, it helps us to be able to help each other. So let's try to keep that in mind. And I remember we talked about doing everything in inches. So this piece right here, this unknown height of the chair, what does it correspond to on the other triangle? Okay, how tall is that person? 76. So X corresponds to 76. I'm putting them below each other. So it's the chair over the person. I need another term from the chair. 72 corresponds to what on the other one? 48. And the cool thing we learned about these fractions, when you have inches over inches, they cancel. So you can do that. It doesn't help a whole lot right now. Cross multiply. See what you get for X. So I hear that we got 114 inches. Now, if I told you to go walk 114 inches, you'd probably look at me like I'm crazy. But if I told you to walk this distance in feet, you could probably visualize it a little bit better. So let's change this over to feet. How can you convert that to feet? Divide by 12. So 114 divided by 12, and what do you get? It tells you 9 foot 6 inches? Okay, now it says 9.5. I'm going to help people on how to deal with that 0.5. So here's what you can do. What is 9 times 12? Is it 108? But how much do we have left over to get to 114? 6. So that's that 6 inches that she just said a little while ago. So whatever you have left over, we had 114 minus 108. We knew that went in evenly. We were left with 6 inches left over. So we had 9 foot, 6 inches remaining. So 9 feet, 6 inches is our height on that chair. 9 foot, 6 inches. And in architecture, a lot of times, construction, they'll say 9 foot, 6 inches. That'll be how they write it. A quick hint is to redraw the picture. How long is the shadow? Well, here was their shadow, so we'll call it our X this time. And the person is 4 foot 9 inches. 4 foot 9 inches. But we knew some measurements on this chair over here. How tall was that chair? 9 foot 6 inches, or you could say 114. That other piece right here was how long? 6 foot, or 72 inches. That should be able to get you to the answer. All right, here we go. I'm going to show you 2 different ways to do this, and either one is fine. First one I'll do is just like earlier. So we'll call the unknown X, and that unknown piece corresponds to what on the other picture? What does this correspond to on the other picture? 72. So we're going to write down 72, and this is in inches. So our answer will end up being in inches. And now, what else do I know on that first shape? Oh, I know 4 foot 9 inches. Well, how long is 4 foot 9 inches? 57 inches. So make sure to write that down. If you haven't done that conversion, could be why you had a little mistake. So we have 57 inches. How did we get 57? We did 4 times 12 plus 9. And 57 corresponds to 114 inches, which we found earlier. You cross multiply, that's going to give your answer. So cross multiplication here will give us that X is 36 inches. You could have also put your answer in feet. How many feet is that? Divide by 12. You get 3 feet. So either 36 inches or 3 feet would be the correct response.